I told you this the other day, and somebody refuted this, but I like to take the questions that we struggled on collectively and kind of sprinkle our exams with some of those questions to see if those people that struggle on it are being students. And part of being a student is recognizing the feedback that you get on tests and quizzes and then targeting those areas, okay? I want to see if we're doing those things, okay? So, looking at this one, remember the domain and range. So this is the idea here. These were each worth 2 points for the domain, 2 points for the range. And I tried my hardest not to subtract 2 points from them, unless, obviously, you were completely off base or you just didn't answer, okay? So, a lot of you had like minus a half, minus a fourth, minus 3/4, minus 1. No. So, looking at this, what we're trying to do with all of these is identify the x values that would exist, okay? So I'm going to look at this interval right here. Would you guys agree that if I look at that green interval, there are points plotted on the graph in that green interval? Okay, so this is the idea of domains. I'm looking for x values that the graph is being plotted for. So inside that green region, there are points being plotted, right? So if I were to go through that curve and ask you to write down the infinite number of ordered pairs and put them in order, okay, you would have an ordered pair that has an x value just to the right of -7, right? Okay, so our first domain value here would be a -7. Okay, or sorry, it's -8, isn't it? -8, sorry. -8. Can't read. -8. And then I'm going to keep moving to the right, and as I move to the right, will I have an x value of -7? Will I have an x value of -6? Will I have -6.5? Will I have -7.5? These are all points that would exist, right? So I'm going to have x values of all of the values from -8 all the way up to -2. Does that make sense? Now, -8 is open, -2 is closed. But now, won't I also have over here in the pink x values? What are the x values that I'm using here? 1 to 9, right? 1 should be included. 9 is also included. Okay? That is all we're doing. We're looking for the x values in which the graph exists. The x values in which the graph is defined for. Okay? Does that make sense? Yes, sir. Okay. Now, this is where we really struggle. Okay? Collectively, not some. Yeah, exactly. So when I am going to look at the range values, I'm now looking for all of the y values that are getting used. Okay, all the y values, if I was to write all those infinite ordered pairs, what would be the y values that exist? So I'm going to start highlighting there. Would you guys agree that I have a y value of, what is this, -6? Okay, so we're looking at the numbers that are below the line. So -6. That would be a y value right there, correct? Okay, so that point right there is going to be on. So -6. Now, as I move up, okay, will I continue to have y values up to 1? Yeah. Okay, and I'm going to see y values up to 1 over here, right? But does this keep going up? So will I have y values that are bigger than 1? I'll have y values up to 7, right? Does that make sense? Now, I was just looking at kind of this branch of the curve,
I can look at this branch as well. Do I have y values over here that are like -1, -2? But they're also over here, right? Before a function, we're allowed to have repeat y values, right? Okay. So what I'm going to do is I'm going to highlight the region in which this thing is defined for or graphed in regards of y values, in regards to y values. Does that kind of make sense? Okay. In that blue, there is, no matter where you're at on the curve, okay, a y value out of the blue is being used. So we want to say that our our range is from -6. Oh. -6 up to 7. Now here's the idea. We're going to include both those, right? Some people had concerns or issues or were confused about that one right there. Because it was open, they thought, -5 needs to be removed. Now think about this. And I would agree that right there, if I were to ask you that ordered pair, you couldn't give it to me. Because it doesn't exist, right? You could give me like -8. So what would it be? -7.999999999, -4.9999999 as that ordered pair. That's the only one that you can give me there. Okay? So they're like, well, -5 doesn't belong as a y value. Doesn't that point and that point have a y value of -5? So will I have a y value of -5? Yeah. Okay, so it needs to be included in my range. Okay? So a lot of people, as we're going through this, talking about the ranges, where there were open dots. So for instance, I got an open dot here and an open dot there. Okay, for the range, they were getting confused. Because they're thinking, well, that doesn't have a y value. In this case, they're saying we don't have a y value of -4. But isn't there a y value of -4 right there? That's being closed. And they're thinking, well, I don't have a y value of -2, but if I come over here, there's a y value of -2 right there. So those y values do get included. Okay. So now looking at the domain, what's the first x value would be -8, right? Okay. Now I'm going to exclude -8 because it's open. And as I move that red line, or start coloring here, this thing is going to get tossed out the window.
What's different than like last time?
Well, I should be able to just click on those and it just not clicking.
Yeah. Is it because it's like old or like an update?
No, it's just I think there's an update issue. But as I keep going through, this blue stuff would all have x values, right? Okay, so we see that we're going from -8 up to 9, right? -8 up to 9. And now 9 was an open dot, so we'll parenthesis that. Now if I want to go my range, remember range is starting down here at -8 now. And I'm going to move this thing up. I'm going to take that up, and I'm going to start just seeing where do I cross the graph, because this is my hope that we understood this. As I take that line through, as I take this line here and pass it through, the hope is that if I recognize that it crosses the graph at least one time, that y value gets included in my range, right? So I go here, and the issue was that was an open dot. But do I at least cross? So I don't cross here. But do I cross here? And do I cross there, right? So that tells me that there are ordered pairs that have that y value. And as I keep moving, there's the other issue. I don't cross here because it's an open dot. But do I cross here and here? Yeah. And I keep going. And I'm crossing. There's the last place I cross, right? So 4 would be the last y value that we have. And we would close that off. Bless you. We all right with that?
Sure.
Okay.
How old is your?
Excuse me?
How old is your new one?
She was born in January, so what's that? About 9 months? See, 9 months. She'll be 9 months in 7 days.
Wait, did you have 2 girls? Do you want it? Yeah.
Sorry, do you want a boy?
Okay. Like I like having girls. Like it's
Well, like, but don't you want like
like when we had Lila. Like I told my wife, when we had Lila, if I had 12 more Lilas, I'd be fine with that. Like that's.
But don't you want a son that can
Keeper probably does.
like your football legacy? Like you got 6'5" like you? Bench monster truck?
I think my youngest might be. She's pretty strong. She was like. She's almost 9 months, and she'll be walking here pretty soon. She's already standing up and pulling stuff up on the couch and stuff like that.
I know sister had her best part till she was 4.
Well, I was like, what, 4 years sooner than you did?
What?
8? All right, so domain here. As I start moving this line through here, as I start moving that green line, okay, we're open here at -9, right? Okay, and now as I move that green line, it's intersecting the graph, right? So I should have x values wherever it's intersecting. But when I get right there, do I have an x value? No, I don't pass through there, right? So -5 needs to get kicked out. Does that make sense?
Yeah.
And now I'm going to continue to move that green line. Okay? Does it intersect through those spots? Right? And then the last kind of place that we intersect on that branch of the curve is at 2. And we will include 2. Now we jump. Do I intersect here? Am I intersecting the graph right there? No. Okay, that green for you guys doesn't look as good as it does on my screen. Okay, so if we're not intersecting there, we can't put those in here. We cannot have those values in here.
That's a terrible color.
What about there? Do I include 4? Okay, so 4 is the kind of the demarcation point, right? But I don't include it. So I have to use 4, but I don't include it. But now as I move to the right, do I kick out any other values? No, so that tells me to go to infinity. So that would be the domain we're looking for. Okay? Now as we do the range, okay, we're going to start with a horizontal line at the bottom. I'm going to start passing it through. Where's the first place that I pass through? -6. Okay? So we include -6. And I'm going to now continue to move that through. Okay? And we get here to 0, right? And there's an open dot right here where my cursor is. Do I kick 0 out?
No, because there's a line there.
All right, it closes here, right? Does that make sense, everybody? Okay. And I get up here. There's another issue because there's an open dot right here. But will I have a y value of 2 in my list of ordered pairs? I'll have one there, I'll have one there, and there's actually an infinite number over here because of that line right there, right? So y value of 2, there's no issue with that. Keep passing that thing through. Where is the issue? Right there, correct? Okay, we've got an open dot there, and that y value is, that was weird, is 5. And we're going to make sure that 5 does not become part of my range. Is that all right? All right, so doing the same thing on these guys. I'll just kind of quickly write these down here for us. This one should be, we start at -7, okay? Now, as I pass through, is there an issue there? Will I have an x value of 2?
Yeah.
Yes, so 2 needs to be included, so I don't kick it out. and then I get up to positive 7, and I should close off. So there's my domain.
Okay. Now, my range. What's my range going to start at?
-6.
-6. And as I move through, okay, some people are thinking, oh, well, there's a problem here because of that open dot, right? At 2. But is there a closed dot there at 2? Is there a closed dot there at 2? So 2 needs to be included in my range, right? So I don't kick 2 out. Are any of these values kicked out? Any of those?
Oh, no, we're in a circle here.
Just the top one, right? So -6 to 4. This one domain starts at -8 again. We go up to 2. Kick out 2. Because here's the thing. Even though they're on top of each other,
In the previous one, there was an open one and a closed one, right? So closed says it belongs. But here it's open and open. So will 2 be
an x value of any ordered pair in here?
Nope.
Nope. And we'll go to infinity. The range, first range, y value would be -4. Okay. Then as I move up, there's an open dot here at 3, but will I have y values of 3? Yep. And I keep going, and I get to 8, and there's an open dot at 8. But there's a line here, so that tells me that there are y values of 8, right? Okay.
Yeah, I messed up too. I missed the dumbest thing.
And the last one should be, so we go -infinity up to -3, and then we union 2 to infinity, and the range here, because of these arrows, are -infinity to infinity. I think everybody got that right.
No, I got that.
Well, did you say that your first range value was that? So this is the reason why I did this. So collectively, for the most part, I think we did all right on this one. But that's open, right? So a lot of people said, if you missed it, maybe you started with 4, and then started looking up. But remember, and that's why I cut this arrow short here. That arrow means it keeps going forever that way, right? So the first y value you actually encounter is -infinity.
Did you trick me?
One thing I did see, we talked about this in the last class as well, is like this one here. When we're writing this domain, and I gave points for this, I probably shouldn't have. But what people were doing is they're saying, okay, I'm going to look at behaviors of the graph, which is good because we will need this concept later, but they're saying right here, I notice that there's a behavior happening, basically say that graph is increasing. Right here, our graph is constant, and then right here, our graph is increasing. And then they said, well, right here, it is decreasing. And then here they started to say, well, from to the right of that point, it is now increasing again. Does that make sense? Can you see those different behaviors? And we'll talk about that's an application, it's a concept of functions of talking about when they increase and decrease. And that will be important for a lot of things that we do. So what they did in identifying the domain is that they went and identified basically these intervals of different behavior. They said, well, from -8 up to -5, we were using those x values. But then from -5 to 2, is that -2? No, -3. It was doing something different. And then from -3 to -2, it was doing something different. And then from 1 to 5, it was doing something different. And then from 5 to 9, it was doing something different. And then they wrote all those down. and then union. So we got a lot of unions here. And I'm going to say, yeah, you're right. You gave me the domain. You 100% gave me the domain. There's not a single x value, the way you wrote that gets kicked out. But think about this. Why write it this way? Why write it that way? Because now we're saying -5 belongs to the interval on the left, -5 belongs to the interval there on the right. Did -5 get removed? No, right? -5 is part of my domain. Let's leave it in there. Okay, so those two intervals are better written as -8 to -3. But then the argument is, well, we did the same thing here. -3 is included in the middle one, it's included in the right one, so -3 doesn't get kicked out. So from -8 up to -2, we're not kicking anything out. So why not just write -8 up to -2? Does that make sense? Okay? So just be cautious. There will be times, guys, and you got to pay attention to what we're looking for. There will be times where they say, what's the domain? And we write -8 to -2. And then there will be times when they ask you, what are the intervals in which this thing is increasing, constant, and decreasing? And then we can break it up like that. Okay? So just be on the lookout for that idea as you're working through these. What is the domain concept here that gives us a problem? Division by 0. Okay, so we need to take that thing and see where the bottom would be 0. Okay. So now you got a factor, right? This is the AC method. Okay, and I'm going to tell you that eventually factors to x plus 1 and 4x minus 3. Okay, so then we say that x is equal to -1 and x is equal to 3/4. But remember, we're really saying where x cannot be those things. AC method. 4 - 3 gives me -12. And I think about two numbers that multiply together give me -12 and add to give me 1. So this thing is going to actually turn into, I'm going to rewrite it as 4x squared plus 4x minus 3x minus 3. Remember doing that?
Yeah, when I did this in my paper, I did it in my head, it was a stupid idea, and I got 7. And I was like, well, no two things do that.
Right.
And then I was like, negative.
If you forget the AC method, you use quadratic formula. And that would have given you the 3/4 and the -1 as well. Now here's the thing. I gave you 1 point for doing that. Okay? Now I want you to be able to write the domain. So remember this. What we do, and some of us that are missing these, I suggest you maybe draw a picture until you can visualize this in your mind without a picture. Draw your number line. Remember our domain, we always assume is all real numbers, right? So -infinity to infinity. That's the assumption as we start. Okay? Now I've told you that we can't use -1, and I can't use 3/4. So now the question is, well, how do I, in interval notation, represent everything that is green, right? So in interval notation would be going from -infinity up to -1, union, -1 up to 3/4, union, 3/4 to infinity. Okay? And I give a point for that. My thought, guys, is that, yeah, we can do the work. You can tell me that x does not equal -1, x does not equal 3/4. But then how, my goal for you is not only can we do the work, but can you tell me what that means? Okay? Can you tell me how that relates into a domain? And write the domain in interval notation. Okay? Is that all right? Is that a question, Cole? Or? No. All right. What about the next one? What's the issue there? It cannot be negative. Okay? So again, I did this on purpose. I structured this way on purpose so we pay attention to detail. Can't be negative. Get -4x greater than or equal to -19, right? Yeah. X then. This will give you 19/4, right? I divide by a negative. What do I got to do with that? Flip it. So now, remember, we assume all real numbers, -infinity up to infinity. And now this is saying
You're only going to be allowed to use things from the left of 19/4, things that are less than 19/4. So how do I, in interval notation, identify that? Negative infinity, up to 19/4, and I bracket. Okay, so this one, what's the issue here? Can't divide by 0. So I think everybody can argue that that's positive -5, right? Is there a concern here? Yeah, okay. A lot of people wrote their answer as like negative infinity up to -5, union 5 to infinity. That's wrong, okay? Because you've got an issue here. You got 7 minus 3x has to be greater than or equal to 0, right? When I do that, I get x to be less than or equal to 7/3 when I solve that. Now remember, you need a number that is defined as your output here for your numerator. You also need a number defined here, but also that number cannot be 0. Does that make sense? Okay. So we're looking for this to be true and that to be true. So if I look at a number line here, I think about my domain, okay, we just found, I don't know the best way to draw this, -5 and +5. We just found that, right? 7/3 is right there. Now, if I write we're not allowed to be -5. Terrible. Not allowed to be -5. We're not allowed to be +5, right? It also said we had to be less than 7/3. Okay? We're looking for the overlap, right? We need the and. Okay? So this says I have to have things that are less than 7/3. Does that make sense? I have to have that. But can I use -5? No. So I'm going to use values that are less than 7/3. But I can't use -5, so it's going to look like this. That's a 5. Having issues. That's a -5 there. So negative infinity up to -5, union, then -5 to 7/3, and then close off 7/3. You have to have the end. There's no problem with -5 in the numerator. If I plug -5 in up here, okay, -5 plugged in there gives me 7 minus -15. That's, what is that? 7 minus -15? 22, right? Okay. Can I take square root of 22? Yeah. If I plug it in here, what do I get? Get 0, right? That's a problem, correct? Okay. Now, the argument is, well, what about 5 over here? Why didn't I include that? Well, there's two reasons to include 5. One, I plug 5 in there with 7 minus 15. Yeah, radical -8, right? And on the bottom I get 0. That's a huge problem. You got an imaginary number divided by 0. What does that even mean? Okay, so you can't do it. All right. Everywhere else in this interval provides you a real number divided by a real number, and the denominator not being 0. All real numbers here, right? I think we all got that.
Yes, sir, I got that right.
All right. So this next one was a little bit. So remember, my goal for us is to think, right? I had a professor in college that you should learn something on every single test that you take. Okay? And what he meant by that is, in my opinion, is that you should learn something about you on every single test that you take. You should learn something about paying attention to detail. You should learn something about maybe your study skills. You should learn maybe even a new problem or new type of problem, how to address it, if you understand the mathematics. I told you that you can never take the even root of a number, right? Or a negative number, right? But when we got to odd roots, it was perfectly fine to take the odd root of anything, correct? So a lot of people saw, it's cube root, no problems there. I can take the cube root of negative, zeros, and positive. So there's no issues with this top one. And they say, okay, I'm going to separately look at the bottom one and say, I can take the fifth root of anything. That's just like the third root. No problems. So they wrote negative infinity to positive infinity, right? And you got a lot of right answers there, but you got one answer in there that is wrong. Because what am I never allowed to divide by?
0.
Okay? So, even though I can take the fifth root of 0, if I plug 1 in here, okay, think about what I get up top. I get cube root of -9 up top when I plug 1 in. I can do that. That's fine. That's a number. Okay? When I go on the bottom, I can take the fifth root of 0. And that's fine. It's 0. It's a real number. I get a real number divided by a real number, but can I take a real number divided by 0? No. So 1 needs kicked out. So negative infinity up to 1 union 1 to infinity is what we're looking for. All right? And I think that's an attention to detail type thing. I think we look at him and say, oh, he said we could, as long as this index was odd, we're fine. Remember, we're still dividing here. Spent a lot of discussion time in.
My hopes were that we would be successful in this question. I didn't count this question wrong in your total, okay? So I swiped through it, told you slope, but I didn't count it against you in your total. But we did quite a few demonstrations about talking about how that thing is just the slope, okay? Where this, you remember we talked about that is the difference in your x's as those 2 points get closer and closer to one another of your secant line, and this here, your numerator, is the difference in your y's. As you work through these, I'll let you match your answers up. So we should have an a squared minus 4a plus 1. I think everybody got that right. This, I had people write this, and only that, and so you missed some points on that. We need to simplify, and we get this. And what we missed there, a lot of times, was the 2AH, when I FOIL that out. Is that okay? And the last one, obviously put that. Sorry, I circled the wrong one. So I staggered these so you had some assistance in this process. You take that, and then you subtract this, right? So when I subtract this, I'm subtracting the quantity, so it's going to look like minus a squared plus 4a minus 1, right? Yeah. And it'll be all over h. Then the h's will cancel, and you end up with 2a minus 4, was it plus h? Okay. And that should be then that final one. How do you pull into a parking spot? You pull in from that direction, right? So you as the driver should be reading that 86. This would say 87. That one would say 88, 89, 90, 91, right? Does that make sense? I was impressed with the amount of people that got that right. Have we seen that before, or we just our thought?
The numbers just look funny, so I was like, what if you just turn it upside down? So I turned it around and went, oh. Yeah.
Good deal.